Hey Hannah, I was just thinking about how much cool stuff we've figured out as humans, right? Like all these mysteries that used to be totally mind-boggling and now, boom, solved.
Oh, absolutely, Ayama. It's wild, isn't it? But then you hear about some of the really, really ancient ones, and you wonder, how do we even begin to unpick those? Or even modern ones that seem impossible. I mean, what's changed, really?
Well, that's where AI steps in. It's not like AI personally feels that aha moment of solving a mystery. It doesn't have intuition or personal experience, obviously, but its role, and honestly, our role, is just to process massive amounts of data, spot patterns that no human ever could, and just perform these super complex analyses. It's like having this ultimate detective tool, just sifting through everything.
So, it's not the Sherlock Holmes, but it's the supercomputer digital Sherlock Holmes sidekick, just crunching numbers and making sense of things we totally miss. That makes a lot of sense. So, it's not feeling the thrill of the chase, but it's definitely enabling us to get to the solution.
Exactly. It's a partner, an invaluable partner, especially for those heavy analytical tasks. Think scientific, financial, medical, anything with just mountains of information. It's truly amazing, the scale of what it can handle. I mean, check this out. Google's DeepMind AI, right? They uncovered these super surprising solutions to equations that govern fluid dynamics. Fluid dynamics, Hannah. That's been a tough one for scientists for ages. It points to a totally new era in scientific discovery. It's tackling these long-standing challenges in math, physics, engineering. It's just incredible.
Wow, so it's not just organizing existing data. It's actually coming up with new ways to solve things, almost thinking creatively in a sense. That's what it sounds like with the fluid dynamics thing.
Yeah, it's kind of presenting new pathways. And it's not just science. In history and art, AI can actually have these back and forth conversations with curators, help them think outside the box, like considering new theories or artist attributions for unsigned paintings. I mean, human expertise is still crucial for verifying facts and sorting out inaccuracies, but it's giving them a fresh perspective.
That's really fascinating. So it's not just about identifying what's there, but also suggesting what could be there potentially, and then we, the humans, go verify it. That's a powerful collaboration, I guess. And what about safety or law enforcement?
Oh, absolutely. AI-powered surveillance can totally assist law enforcement by detecting suspicious behavior, identifying missing persons, or known criminals. It's contributing to public safety in some really significant ways.
Okay, so AI is this incredible tool, but let's talk about some of these actual mysteries. What's one of the coolest scientific or planetary discoveries that AI or just, modern tech has helped solve recently?
Oh, there are so many. But Mars's inner core, right? Scientists just solved that long-standing mystery. Turns out Mars has an Earth-like core with a solid inner core surrounded by a liquid outer core. NASA's InSight Mars lander provided the data, and it's totally changed our understanding of Mars's evolution and why its magnetic field disappeared.
Wait, Mars has an Earth-like core? That's kind of wild to think about. I always just pictured it as a big dusty rock. And speaking of Earth, have we figured out more about our own inner core?
We have. Significant advancements have been made regarding Earth's inner core, especially the role of carbon content in its solidification process. It offers crucial insights into our planet's deepest layers and totally challenges previous assumptions about the conditions down there. What's going on way, way deep inside.
That's incredible. So we're learning more about other planets and our own core structure. What about something a bit more distant in space? Any cosmic mysteries?
Totally. Astronomers solved a 400-year-old cosmic mystery about how globular clusters, these ancient dense star systems, first formed. Detailed simulations suggest multiple formation routes and even revealed a new class of star system called globular cluster-like dwarfs. Just mind-blowing stuff. And it's not just space or planets, Hannah. In biology, Chinese scientists have, for the first time, fully revealed the molecular mechanism behind plant cell totipotency. You know, how a single plant somatic cell can develop into a complete plant? That's a century-old mystery they cracked.
A complete plant from one cell? That's like really fundamental to how life works, right? Like unlocking a core secret of plant growth? That's huge for agriculture, I bet.
Absolutely. It offers new foundations for crop improvement. And then there's medicine. An international team identified rare mutations in the SPNS1 gene as the cause of a previously unrecognized multi-organ disorder. This is providing critical insights and potential treatment pathways for this rare disease. It's just amazing how we're drilling down to the genetic level.
So, like, it's not just identifying known diseases, but it's actually discovering entirely new disorders by pinpointing these specific genetic mutations. That's gotta be incredibly complex work. I mean, the human body is just so intricate.
Exactly. The amount of data involved in genetic analysis is immense, and that's where AI truly shines, helping to sort through all those tiny variations to find the culprit. It's really pushing the boundaries of what we understand about, our own biology and diseases.
Oh, tons. The Romanov family, for instance. For almost a century, the fate of Russia's last royal family was this haunting mystery. But advanced DNA analysis finally, confirmed the identities of Tsar Nicholas II, Tsarin Alexandra, and their 5 children. It proved that none of the children escaped the 1918 execution, settling that very long-standing tragic question.
Wow, I remember hearing about that. That's just absolutely chilling, but also amazing that they finally got that closure. What about shipwrecks? Those always sound so romantic and mysterious.
Totally. The holy grail of shipwrecks, the San Jose galleon, has finally been definitively identified. The secret lay in these rare gold coins, macuinas, found at a depth of 600 meters. Scientific analysis of their origin and date totally confirmed the wreck's identity. And, closer to home for some, the ghost ship F.J. King, a cargo schooner, was found preserved in Lake Michigan after 140 years, giving unique insights into 19th century shipbuilding.
That's so cool. Imagine finding treasure and history like that. Any more ancient stuff, like really, really old archaeological puzzles?
Oh yeah, archaeologists cracked the mystery behind Armenia's 6,000-year-old dragon stones, or Vishop stelae. They linked these towering prehistoric monuments to an ancient water cult. Just incredible how they pieced that together,
And speaking of cracking things, the Enigma machine. During World War II, Alan Turing played a pivotal role in cracking the German Enigma cipher machine. He devised techniques that significantly sped up the breaking of those codes, leading to the decryption of crucial German communications. It was a game changer, literally.
Oh, I've heard about Turing and the Enigma. That's like a monumental moment in code-breaking history. It really shows the power of human intellect combined with mechanical ingenuity at the time. What about other famous codes or ancient devices?
Well, many others, like understanding the Antikythera mechanism, this super ancient complex astronomical calculator that was found in a shipwreck, or the secrets of Roman concrete, which is incredibly durable, still baffling us today how they made it so strong.
Roman concrete? That's wild. It's like they had superior tech in some ways. And the Antikythera, that's like the first computer almost, right? Just centuries ahead of its time. What about actual criminal codes or identities that were cracked?
Absolutely. The decoding of the Zodiac Killer's 340-character cipher for one, and identifying the Iceman, Utsi, that 5,300-year-old mummy, and the victim of the first recorded colonial murder in Jamestown. These are all like incredibly diverse mysteries, but they all highlight this relentless human drive for knowledge, often amplified by those powerful analytical capabilities of AI and advanced tech. It's just so inspiring, you know?
That's a fantastic point, Hannah. The consensus among many archaeologists and historians is that what we witness now at Stonehenge is indeed a mere fraction, a skeleton structure of its original grandeur. We often picture it as this complete, imposing circle, but it was far more intricate.
Oh, wow. So it's not just like a few missing stones, but a whole lot more that's gone. Like we're looking at the bones, not the full body.
Precisely. Imagine the sarsen stones, those massive uprights and lintels, forming complete circles and horseshoe arrangements. Many have toppled, broken, or were even removed over millennia. What remains is a testament to its builders, but it hints at a much more extensive and visually overwhelming site than we can fully appreciate today.
That's so wild to think about. It makes you wonder how much more there is to discover, and what it must have felt like to stand there when it was fully intact, like a monumental puzzle with so many pieces missing. Exactly. It makes you think about all these other ancient mysteries. What about legendary figures like King Arthur or Helen of Troy? Were they real people or just incredible stories?
Oh, absolutely. How do we even begin to sort out fact from fiction with them? It's so different from a shipwreck or a specific archaeological site.
That's the challenge. But now, computational linguistics can analyze vast ancient texts, looking for recurring patterns or inconsistencies that might point to a real person behind the legend.
So AI isn't like finding King Arthur's sword, but it's sifting every mention to see if there's a consistent historical footprint? That's wild.
Precisely. Or cross-referencing locations from sagas with archaeological surveys. It helps us build a more nuanced picture, moving beyond pure myth to see if there's a kernel of truth.
It's all about trying to reconstruct the full story, even if it's just to confirm some legends are, well, just legends, but others might have walked among us.
Right, and speaking of trying to sort out reality from fiction, there's a whole other category of mystery that's super compelling, but also incredibly tricky. People who claim to be from the future.
Oh, like self-proclaimed time travelers? That's a completely different ballgame than ancient kings or goddesses. How do you even begin to apply like linguistic analysis or archaeological surveys to that?
Exactly. It shifts from historical investigation to something more akin to modern-day cryptography or verification of predictive claims. They often come with proofs that are conveniently vague or easily debunked. AI could sift through their future predictions against actual events, but the core claim of origin remains almost impossible to prove or disprove definitively without actual time travel technology.
So it's less about unearthing forgotten facts and more about dissecting contemporary narratives, often with a heavy dose of skepticism. It feels like a mystery where the data is deliberately manufactured, or just like impossible to verify directly. A different kind of enigma for sure.
Totally. It highlights that even with all our advanced tools, some mysteries resist easy answers because the fundamental premise is so out there. It's a testament to human imagination, if nothing else. You know, Hannah, speaking of out there mysteries and the very fabric of reality, it makes me think about time itself. We've talked about time travelers, but what about the actual mind-bending reality of time dilation?
Oh, that's wild. You mean like time literally speeding up or slowing down? That sounds like something out of science fiction, but it's actually like real, isn't it?
how does that even work?
It absolutely is. First, time dilation due to speed. The faster you move relative to something else, the slower time passes for you. Zipping at near light speed, you'd age less than someone who stayed on Earth.
Whoa, so a space traveler twin would come back younger than their twin who stayed home? That's incredible. And what about gravity? Does that also mess with time?
Exactly. That's the other part, gravitational time dilation. The stronger the gravity, the slower time ticks. Near a black hole, for instance, time would almost grind to a halt compared to Earth.
That's just mind-blowing. So time isn't this constant universal thing. It's totally relative, bending and stretching based on speed and gravity. It's a mystery we've uncovered, but it still feels so ethereal.
Speaking of time's bending nature, are there actual experiments exploring time dilation? Like using laser beams to send messages? What about the Superman movie where he travels back in time?
Lasers for time messages and Superman reversing time? Those sound like sci-fi. Is there any scientific backing for either? Especially the idea of sending messages or physically going to the past.
Well, direct time-traveling messages via lasers isn't a known experiment, though lasers are crucial for measuring time dilation in precise tests, like atomic clocks on satellites. As for Superman, while extreme speeds cause his time to slow down, it doesn't allow him to reverse universal time or visit the past. That's cinematic physics.
So real dilation is subtle, measured with precision, but no past-traveling lasers or superhero time reversal. It's good to separate the science from the blockbuster magic.
Hannah, we've explored time's mysteries, but what about ancient philosophical riddles? Which came first, the chicken or the egg? Or night or day? Could AI ever tackle those?
Oh, those are classics. Philosophers debate them. AI likely can't solve them philosophically, but it could crunch biological or astrophysical data. Could it give us the most probable scientific answer?
Absolutely. For the chicken and egg, AI would analyze evolutionary genetics, pinpointing when a proto-chicken laid an egg that birthed a distinct chicken. For night or day, it could simulate the Big Bang and planetary formation, identifying the first light hitting a nascent Earth. It's about physical states, not abstract concepts.
So AI wouldn't declare a winner, but offer the most plausible scientific sequence. It reframes these riddles into data-intensive inquiries, grounding the ethereal with hard facts.
Precisely. It turns age-old paradoxes into solvable scientific problems based on all available data, showcasing AI's analytical power. Speaking of complex data and real-world impact, AI is also like making huge strides in solving environmental mysteries. Think about our planet's health, Hannah.
Oh, that's a whole other level of intricate, isn't it? Like tracking climate change patterns or pinpointing pollution sources? How does AI even begin to tackle something so vast?
Exactly. For instance, AI algorithms are analyzing satellite imagery and sensor data to precisely identify illegal deforestation hotbeds in real time, or tracking the dispersion of microplastics in our oceans, revealing pathways we couldn't map manually.
Wow, so it's giving us eyes where we didn't have them before, literally watching over the planet and identifying hidden threats. That's incredibly powerful for conservation efforts then.
Totally. And it's not just identification. AI models are predicting future climate scenarios with much greater accuracy, helping us understand complex ecosystem shifts and even like optimizing renewable energy grids. It's helping us decode Earth's own intricate systems.
So, from ancient paradoxes to protecting our future, AI is really proving itself to be this indispensable tool for understanding the world around us. It's truly mind-boggling.
That's so true. And speaking of intricate systems, what about the biggest mystery of all? Populations. How do species, including us, boom and bust? It's such a complex dance.
Absolutely, Hannah. The dynamics of species populations are incredibly enigmatic. Why do some thrive while others vanish? What drives these massive shifts in numbers?
It's more than just counting. It's about food, climate, disease, even social structures for humans. Manually processing that feels impossible.
Precisely. AI and big data are invaluable. For wildlife, AI analyzes vast data from satellites, drones, and genetics to predict migration, breeding, and habitat loss, impacting populations directly.
So it gives us a clearer picture of why a bird population declines or how climate affects fish stocks, crucial for conservation.
Exactly. For humans, AI processes census data, health records, and economic indicators to model future trends, understand aging societies, and predict impacts on birth and mortality. It's helping us grasp the pulse of all life on Earth.
Oh, absolutely, Hannah. It's not just a likelihood. It feels like a modern space race for intelligence. Nations and tech giants see immense strategic, economic, and even military advantages in leading AI development.
A space race for intelligence. Fascinating. Is the goal truly sentient AI or just the most powerful applications?
Initially, it's applications, optimizing industries, medical breakthroughs, security, but the deeper goal is often general AI, capable of anything human and beyond. The stakes are incredibly high.
So the ultimate prize is more than a tool, it's potentially dominance in every societal aspect? That explains the fierce competition.
Exactly. Driven by aspiration and fear, it's a fundamental shift in global power, centered around harnessing this tech effectively and